Hello everybody. In this video, I will explain you the concept of finding the candidate keys for the relation with the given set of functional dependencies. If every attribute of the relation is determined by a particular attribute, say A, then A is said to be the candidate key of that relation. The key attribute is determined by finding the closure of the attribute set. Already in a video, I have explained you the concept of finding the closure of the attribute set. The link is given in the description box. Now, we will discuss about how to find the candidate keys for the relation with the help of the given functional dependencies. For the given set of functional dependencies of the general form called as x determines y, we call x as a determinant and y is a dependent. We say an attribute as a key attribute only if it determines all the other attributes. That is, in the meaning that the key attribute will always determine the other attribute. Okay? So, in that logic, we need to identify the attribute that is not present in the dependent side, that is, the right hand side of the functional dependency. That attribute will be a part of the candidate key. Okay, examine the attribute that is not present in the dependent side or the right hand side of the functional dependency. That attribute which is not present in the dependent side of the functional dependency will be a part of the candidate key. Furthermore, whether that attribute is a candidate key or not will be determined only by finding the closure of that attribute. We will see an example for better understanding. Here, they have given a relation with 8 attributes A, B, C, D, E, F, G, H and 5 functional dependencies. Now, they are asked with the question that find the number of candidate keys. So, here 8 attributes are there. Candidate key could be determined only by finding the attribute closure. But for which attribute I need to find the closure? We don't have a hint. So, since our objective is to find the candidate key, so the key attribute will not be present on the dependent side. So examine the attribute that is not present in the right hand side of the functional dependencies, given functional dependencies. So G is there, B is there, C is there. In third functional dependency, C, F and H is there. In fourth functional dependency, on the right hand side, A is there. And in fifth functional dependency, on the right hand side, E and G is there. So the only attribute that is not present in the right hand side of the functional dependency is D. So clearly state that D a part will be a part of the candidate. Now, whether D is the candidate key or not, that could be determined only by finding the closure of D. Okay? So D determines itself and see to the given 5 functional dependencies, D doesn't determine anything else. So D determines D alone. So whether we could call it as a key? No, right? So we can call an attribute as a key attribute only if it determines all the attributes of the relation. So D is not such attribute, so it is not a key. Now, what else we could do is we have identified that D will be the part of the candidate key, but D itself is not a candidate. So what you have to do, please check with the other combinations. Combinations with D. You combine AD and find its closure, BD closure, find the CD closure, find the DE closure, find the DF closure, and find the DG closure. Also find DH closure. Combination of D with the other attributes. Okay. So now if you find the closure for all this, you will get the answer for the number of candidate keys. Okay, so we'll proceed into it. So AD determines itself. So first of all, AD determines AD. From the given set of functional dependency, you have to, what is the concept here is as and when you add the elements here in this closure set, the newly added element separately or as a combination, it is determining any new attribute that have to be checked. If any new attribute is determined by this attribute, then it is also to be added here. Okay, so on that aspect, A determines B and C. So B and C in functional dependency 2, A determines B. So added B and C to the set. B alone not determining anything. B alone determines C, F and H in functional dependency 3. So already C is there, so we have to add F and H. C alone doesn't determine anything. F alone in functional dependency 5 determines E and G. Stop for a while and check. Here, all the 8 attributes are determined by the combination of attributes A and D. So, AD combination is a candidate key. Likewise, we have to find for BD closure also. So, BD determines BD. B separately in functional dependency 3, B determines C, F and H. Now, here are 5 attributes here. Out of these 5 attributes, all the 5 attributes individually or as a combination determine any new attribute means add it here. So D alone doesn't determine anything. C alone doesn't determine anything. F determines E and G. In turn determines A in functional dependency 4. So here all the 8 attributes are identified that determined by the attribute combination BD also. So definitely it is also one of the candidate key. Similarly, find CD closure. CD determines itself. C separately or D separately or CD combination doesn't determine anything here. So since it doesn't determine all the attributes, it is not a key. Now we'll go for DE closure. DE determines DE. D separately doesn't determine anything. E separately in functional dependency 4 determines A. Now this A separately in functional dependency 2, it determines A alone determines B and C. Then in functional dependency 3, B determines C, F and H. F determines EG in functional dependency 5. So E is already there, so G will be added. Now here you can identify that all the 8 attributes of the relation is determined by the attribute combination D and E. So definitely DE is a key attribute. Proceed with DF. DF determines DF. D alone doesn't determine any other attribute. F alone determines E and G added here. So this E separately as alone determines A mentioned in functional dependency 4. A determines B and C. B determines C, F and H in functional dependency 3. So C is there, F is there, H has to be added. So now again DF determines all the 8 attributes of the relation. So DF is also the key attribute. Go for the next. So DG determines DG. D alone doesn't determine any other attribute. G alone doesn't determine any other attribute. So DG determines DG alone. So definitely, since it is not determining all the attributes of the relation, it is not the key attribute. Similarly, find DH closure. DH determines DH. D alone doesn't determine anything. You can see the left hand side. D is not present. That means D is not determining any other attribute. H also doesn't determine any other attribute individually. DH combination also doesn't determine any other attribute. So, therefore, we can conclude that DH is not the key. Now, count the number of keys here. Okay? So, that is the answer. Okay? The candidate keys. The candidate keys are, we have identified that AD determines all the attributes, 8 attributes. BD determined all the 8 attributes. DE determined all the 8 attributes. We have determined all the 8 attributes. So the answer is 4. This is how we have to find the candidate keys for the relation. Hope you understand the concept. Thanks for watching.